Morning, Manada. Myself, K. Balakrishna, Assistant Professor in the Department of CS and AI, SR University. Today, I am discussing topic of queue using linked list. So, in previous video, just we completed stack using linked list as well as queue using array. So, in this class, just in this video, just I need to complete queue using linked list. So first, again, I'm giving one definition for your for queue. So queue is it is a first of all it is a linear data structure. Then it follows first in first out or last in last out operation. Okay. So in previous example, if I'm going with stack, there is only single hen like so here just if I'm taking this is my stack. If I'm consider this is my stack. So this has only single n. So always insertion as well as deletion, both operations should be done at one end. That is called top. So this is stack. Okay. So coming to here in queue, we have two ends. One is rear and other one is front. All the entries should be possible with rear end. Exit should be with front end. Usual examples are cinema ticket on queue line as well as paying the bills, uh, railway ticket reservation counter, taking the tickets, etc. Clear. So this is first comes first serve, like so first in first out. Okay, just we are discussing this one with linked list representation. Clear. So, so this has two operation. One is insertion operation. Second one is deletion operation. As well, also we need to display uh, peak element also. So basic operations is insertion as so called as NQ operation, deletion, DQ operation. Always insertion should be done at from array. So deletion should be done at from right. Okay. So here the end. So the entry should be done with from rear. The exit should be done from front on. Clear. So in this way, just we need to implement NQ and DQ operations. Let me check with the example. This is my queue. Okay. This is not required. Earlier we saw this one. Just we are going with one example here. Okay. So just I am taking one queue here. First I'm taking one queue here. Okay. So this is I'm trying to join one queue. Okay. So always from this way. Okay, here this should be rear front clear. So meanwhile, in the just we need to going so using linked list always we need to insert the data in the form of nodes. Clear. So further just we need to create one node. So with the help of some memory address, okay, in very basic, so it should have some data. 10. And the first one part is again null. Okay, obviously the insertion should be done from the rear end. So here we need to insert the data from rear. Okay, the data in the sense node. That node should be present here. So that is called here. Very first case, this is new node. That new node will be inserting into the queue with the help of a rear pointer. Okay. So very first case, this is one. So in similarly, just I need to add one more node. Okay, add one more node here. Okay. Next. So in the it has some address 2000. So it has some data 20. So again, it also null. Why? Because the new node obviously creating with null. Okay, how it is, I implement with programmatically. Okay, just what I need to do here, just I need to establish the link in between these two. Okay, why? Because here we need to uh, we need to uh, send or exiting the data from the front. If I'm trying to insert the data from the rear 10, that should be the exiting in from the front as 10 very first. Okay. So I need to establish the link like this. Okay. At that case, I need to replace my null with here 2000. Clear. So this should be reference to the pointer that is. So this one is friend. Okay, very first case, this one is friend. So that should be had only 1000. Okay, here again, here this one is rear pointer. Okay, the rear pointer should be very first case. If there is no data, it should be 1000. So again, it also pointed to here. In second case, this link should be destroyed and we need to replace the 1000 with 2000. Why? Because always we need to insert the data from the rear only. So that's why the rear pointer should be modifying each and every insertion. So I'm trying to take one more node here. Okay. So here just 30 is my data. Next one is null. Okay. So this one has 3000 memory location. So we need to insert the node into the queue with the help of rear. Okay. So just what I need to do here, just I need to replace the 2000 with now 3000. Okay. So earlier the link is the 2000 link is from here to here. Again, this one also destroying. So now the 3000 is pointed to here. Clear. So now the front is always pointed to the front element. Okay. The rear is so the best thing is while insertion rear value or rear pointer modifies and front should be constant. Is this clear? Okay. This is for insertion. If I'm coming to one more point, for deletion, insertion in the sense NQ, for deletion, friend friend values modifiers. Friend values in the sense the pointer value that is address only. Twice. And rare should be constant. This is the most important points regarding NQ and DQ operations for Q. Clear. So this is in this way, just we need to insert. Okay. And next thing, just we need to establish the link in between these two again. So at that case, we need to replace the null with again 2000. Sorry, 3000. Then the link will be added to here. Okay. Now, so 10 is the data, 2000 is the next node address. Okay. 20 is the data, 3000 the next address. Okay. Here this my queue contains only 3 nodes. Clear. Here this is called queue. Clear. Okay. So for insertion, just we need to implement the insertion. After that, just we are going with deletion. Okay. Further, just yeah, what we need to do? We need to create one structure. Okay. Why? Because we are going with a linked list. Obviously, we need structure that is called node. So in that we have one data pod. Okay. Next, 2 pointers. Struct node asterisk print comma save. These 2 pointers are required here. Okay. So after that, globally, just I'm trying to declare one new node. Struct node asterisk new node. Okay. Strip new node. So if possible, you can replace with null value. Okay. So next. So what is the first thing? Void enq. Void enq operation. Okay. You may pass the data from your main method, no problem. In that case, you need to take the parameter integer var. Okay. What we need to do here, very first case, we need to allocate memory for the structure that is new node. New node. Okay. What is the syntax? Malloc size of structure of node. So this will be written a pointer address. That's why I'm typecasting here with struct node point. Clear? So now the memory will be allocating for the new node. Okay. Yes. Next, what we need to do? Just I need to check whether this new node is any null. Then what we need to do? Just simply printf q is underflow or empty and memory not allocated. Clear? Okay. If the new node is null, the memory will be allocated. So next, what we need to do, if friend is null, find where is null. So what is the case here? If friend is null and where is null, in the sense the queue is empty here also, same thing. Okay. So in that case, what we need to do, friend is equal, rare is equal, new node. What is the case here? So very first, if it is the queue is empty, just I need to insert the node into the queue. What is the node? The 1000. Very first node is 1000. Very first case, the front is pointed to 1000 as well as the rear also pointed to 1000. Okay. So for that, if front is null and rear is null, if the queue is empty, queue contains, we need to place only single node. Okay. The front also pointed to single node and the rear also pointed to single node. Clear. Else, else, if already a node is existed, clear. So in which way we need to insert the data here? We need to take the help of rear pointer. Okay. What is the rear here? 1000. 1000 next should be null earlier. So we need to add the data of new node. Can I write like this? Where next is equal new node. Yes. Okay. Rare next is already one node is created 2000. The null is replacing with here 2000. New node address is 2000 is replacing. Okay. Then I need to move my rare from here to here. So for that, just I need to write rare is equal, you know. Now the 1000 is replacing with 2000. This is clear. Here the 2000 is overwritten. Clear? Anything else here? Okay. So just in this way, just we need to perform the NQ operation. Okay. So shall I remove this one? Okay. Just here, the data is there. Okay. So we need to perform the deletion operation. Okay. We need to perform. So here, I'm drawing again the queues here. That is time taking process. That's why we are utilizing this diagram. Here, 10, 2000, 20, 3000, 30, null. Okay, these are the memory locations. So if I need to remove the data from the queue, so obviously the first node should be removing from the queue. Okay, so the 10 is removing from the queue. So that's why just we need to write the logic for this. We need to display the front data. Okay, front data. Okay, next, what I need to do? This node should be removing, deallocating memory for this one. Okay, for that we are taking the help of one temporary node. Just we need to display this one. After that, just we need to free this one. Okay, clear? How it is? Just we saw with this with the code. Okay, so further just you need to write here void dq operation. Just in that again we need to check if front is null and rear is null. What is the thing here? printf q is empty. Empty in the sense we won't perform any deletion operation from here. Okay, next. Else. Else part in the sense it contains at least one element. Okay, so further just we are taking the help of one pointer. So another pointer that is a temporary. Clear. So what we need to do here? Else again, we need to check if in your queue only single node is existed. If the single node exists, what we need to do? Here else if friend is rare. So what is the case here? Friend is rare in the sense, so certain amount of time this will be removing from your list. So it has only single node. The friend has 1,000 as well as the rare has 1,000. So at that case, what we need to do here, the friend as well as rare is equal to null. Okay, both pointers should be null. So here there is no need to write this for the single line statement. Okay, next now else what we need to do here? Here just in this case we need to take one temporary struct node asterisk temporary. Okay. So here temp is equal friend. Why? Because always we need to perform the operations from the friend. So just we need to write printf deleted element is percentile d comma print data. So always the friend is this one. Okay. So what we need to do here? After completion of this one, we need to increase my friend from here to here. Obviously, if it is removing, this should be pointed to the next one. Clear. So just here, just we need to destroy the link, this one, and establish the link for this one. So at that case, just what we need to do here, this should be replacing with 2,000. But here we won't touch any rare. Why? Because the rare should be fixed. So in insertion, the friend should be fixed. In deletion, the rare should be fixed. Clear. So after that, just what we need to do? Friend is equal. Earlier, the friend is there. Friend next. What is the friend next here? What is the friend next? 2,000. The 2,000 should be replacing with here. So this will be destroying the link in between these two as well as from your friend. So immediately what we need to do? Just we need to free off temporary node. Clear. Okay. So in this way, just we need to perform DQ operation. So if you are going with void peak element also, if you are going with, if you require, otherwise you need not. Okay. Further, just we need to display, check whether the condition, if it is empty, yes, obviously it is empty. Else printf peak element is percentage thing. So the peak method is available in stacks. If you require, you can implement here also, no problem. Clear. So obviously, the front is pointed to first element, the data. Clear. Done. Okay. The next thing, what we need to do, just we need to display void display. So what we need to do, again, we need to check whether the queue is empty or not. Else, what we need to do here, again, we need to take help of, so after insertion, after 3 nodes insertion, the front should be fixed with 1000, the rear should be fixed with 3000. If I'm trying to take the help of front, I need to display only first node. If I'm take the help of the rear node, I need to display, I'm just display the last node. And in between the front node and rear node, so many nodes is available, many data is there. So for accessing those data with the help of front and rear, it is not possible. So for that, again, we need to take one temporary pointer. So just we need to take the temporary here. Okay. So just here I'm trying to write temporary. So next, what we need to do? Temp is equal front. So it should be starting from my front node. Okay. So next, what we need to do? Y. Just we need to travel from first to last here. This is the first node and this is the last node. I need to travel from here to here. Y. Temp not equal to null. Just what we need to do here? We need to display printf percentile d some space comma temp data. Temp data. So next, what we need to do? Temp is equal to temp next. Clear. So how it works, we'll check with one example. Here, this is the data. The very first case, temp is equal front here. What's the case? Temp is equal 1000. Okay, 1000 not equal null. Yes, obviously here 1000 is not equal to null value. Then just we need to display here. What is the value? Temp data. What is the temporary? 1000 data. 1000 data. What is that? 10. The 10 should be displaying here. Again, the temp is modifying with other node. Okay, temp. What is the 1000? Next. 1000 next is 2000. Okay, again, in next case, so the loop will be continuing here. 2000 not equal to null. Yes, obviously. Coming to here. Now, here 10 is displaying. After that, here the temp has 2000. Next, 2000 data. What is the 2000 data here? Here, 2000 data, 20. So 20 displaying here. Again, 2000 next. What is the 2000 next here? 3000. Okay, 3000 is replacing here. Again, coming to here, next case, 3000 not equal to null. Obviously, it is true. Then 3000 data here. 3000 data. What is the 3000 data? It is 30 only. Next 3000 next. 3000 next should be null. Clear. Here finally null is not equal to null. It is false. So obviously it won't be allowing to entering into the loop. Just it will be terminating after that your next statement will be executed. Clear. So in this way, just we need to perform the NQ-DQ operation with the help of linked list using queue. Okay, so this will be implementing with programmatically. So for that, I'm going with one main method here. Okay, first int value. So I need to read the value as well as I need to take one option. Okay, next while while one always true. So for that here printf one per NQ /n two for DQ /n three for peak /n four for display /n five for exit /n. So what we need to do here, just printf enter your option. Scanf percentile D ampersand var. Okay. Next, sorry, here not value option OPT. Just I need to take one switch case here. Switch. In that I'm trying to pass one option. Case one printf enter data per queue. Next, what we need to do, just we need to call NQ of value, then break. Case two DQ break. Case three P break. Case four display break. Case five exit of 0 break. Default and def invalid option. Okay, switch is done, while is done. Okay, just I need some time to save this one. So we need to import library files or edit files. Include iMode.h. Include lib.h. Let's see, parentheses. Just we have to take care of this. The first, I need to perform the display. Queue is empty. For 3, queue is empty. For 2 also, queue is empty. Okay, 1, 10, 1, 20, 1, 30, 1, 40. Now I'm trying to display what will happen here. So it's not equal to none. Okay. What will the thing happen here? Arrow. Yes, you can execute this code with your another editor. Okay. Thank you for watching.